Hello there, you are warmly welcome to today's video. We are about to solve a question on how to find the relative maxima minima and then the saddle points of a function f of x. So f of x is equal to x cubed plus y cubed minus 3x minus 12y plus 20. So how do we even go about finding this point that we've been asked to do? So the first we need to do is that we need to find the first order partial derivative of the function with respect to x and then y. After that, we find the second order partial derivatives, and then we represent our answer in the form of a matrix. That's a 2 by 2 matrix. Then we find the determinant of the matrix. After we found the determinant, we use the answer from there to find the relative maximum and then the minimal point. It's very simple. Let's quickly go through that. So what we have to do first of all is that we need to find the first order partial derivative of the function. So let me explicitly write out the function. So this is the function. Good. Now we have to find the first order partial derivative. So over here we don't use the y dx, or we don't use this d. We use the partial symbol. So we find the first order, write it this way, partial derivative of f of x. So let's find the first with respect to x, meaning that we are differentiating the function partially with respect to x. So if you are differentiating with respect to x, what it also means is that any other variable that is present in this function, which is not x, is considered as a constant. So when we are differentiating with respect to x, y will be a constant. Although in normal differentiation we would have been able to solve this, we would have been able to differentiate this, but over here we see y as a constant when differentiating with respect to x, and when we also differentiating with respect to y, we see x as a constant. So let's find it. This is the same as fx, okay? So we can write it this way, we can also write it this way. They are the same thing. So when we differentiate this, when we differentiate 3x, we get 3x squared. We get 3x squared. Now y cubed, y is a constant over here, okay? So when we differentiate y, we are going to get 0. When we differentiate this 3x, we get negative 3. This y is considered as a constant. The 20 is also considered as a constant. So the answer for that will be 0. Now after getting this, we have to put this to 0. So we equate this to 0. So that we get our x points for the points we've been asked to find. So we equate this to 0. When we equate this to 0, we are going to get 3x squared minus 3x. Let me write it here. So we put f of x to 0. So when we put f of x to 0, it will be like this equals 0. So let's divide 2 by 3. When we divide 2 by 3, we are going to get x squared to be equal to 1. Then x will be equal to plus or minus 1. The reason why x is plus or minus 1 is because x squared equals 1, x will be equal to root of 1 plus or minus root of 1. And root of 1 is 1, so plus or minus 1. Or another way you could have equally done this is that x squared equals 1, x squared can be written this way. That will let 1 cross the equal to sign. Now 1 can also be written as 1 squared, and this is known as difference of 2 squares. And from that convention, we can rewrite it this way. So having known this, when you equate this to 0, you get negative 1. When you equate this to 0, you get positive 1. So x will be equal to 2 values, positive and then negative 1. Now, what we did here, we are about to do the same thing for y. But before we do the same thing for y, let's find the second order partial derivative of f of x, okay? Okay, so if we have fx to be equal to 3x squared minus 3, we want to find the second order partial derivative. Now we have to differentiate this f of x, or this fx, with the first order partial derivative of the function we have. We have to differentiate this with respect to x, and then after that we differentiate it with respect to y. So we want to differentiate this f of x, we want to differentiate this with respect to x, we write another x here. Meaning we are differentiating the function twice with respect to x alone. So when we differentiate this with respect to x, this answer will be 6x. Right? When we differentiate the 3, we will get 0 for that. Now let's differentiate f of x or the first order partial derivative, let's differentiate with respect to y now. When we want to differentiate it with respect to y, and this can also be written as differentiating it with respect to y, the same as writing it this way, differential with respect to y of differential of the function f of x. And this f of x, initially we have differentiated it in terms of respect to x. So, meaning that we are now about to differentiate a function which has already been differentiated with respect to x to obtain its first order partial derivative. We are now about to differentiate this function again with respect to y. So, we write f y x. Okay. Now, when we differentiate this f of x, fx with respect to y, the answer will be 0 because we say we consider any other thing there as a constant, which is not y. So we are done with this. Now, we'll go and do the same thing we've done for this. We'll go and do the same thing for the y. Meaning we have to also find fy. So the same way we found our fx here, we equated it to 0, we'll do the same thing for the fy. So the fy means that we are differentiating the function partially with respect to y. We are differentiating it with respect to y. And the answer we are going to get for this, let me write that here. So fy, differentiating this with respect to y, x cubed will be 0 since a constant. This will give us 3y squared. This will be 0. This will be negative 12 plus 0 because differential brings the constant, so differential will be 0. Now we put fy to 0, meaning 3y squared minus 12 equals 0. 3y squared will be equal to 4. Y squared, 12. So y squared will be equal to 12 over 3, which is 4. So if y squared equals 4, then y will be equal to plus or minus of 2. Okay, so we are done with that. So having obtained, we had x to be equal to plus or minus 1, we had y to be equal to plus or minus 2. We can write our points from here before we continue to find the second order partial derivatives of the function. So let's say that we are going to get 4 points, okay, because we have 1, 2, 3, 4 numbers. We need to have 4 points. So let's call our points maybe Q. Let's call the next point R. Let's call the next point S. Let's call the next point T. So what we'll do is that when you take positive 1, it's an x value, so we write it here. So positive 1, you match positive 1 to both positive and negative 2. So you match positive 1 to positive 2, you match positive 1 to negative 2. Then go and take negative 1. You match negative 1 to positive 2. You match negative 1 to negative 2. So these are the points we have. It's the same as taking positive 2 and matching it to positive and negative 1. After that, you take negative 2 and then you match it to positive and negative 1. You still get the same answer. So these are the points we have. And it's from this point that we know, it's from what we're about to do that will teach us or let us know which of these points are maxima or are minima and then are saddle. So let's move on. We need to also find the second order partial derivative of fy. Okay, so the second order partial derivative of fy, let's find fyx. Fyx is the same as differentiating with respect to x of a certain function which has already been differentiated with respect to y. Okay, that's what it means. And now this can also be written as d squared fxy. Let me write that here. So d squared fxy. And then the x squared. So this is the same as this, is also the same as this. Okay, good. So fxy will be equal to, first our fy. This is the answer for our fy. Meaning that we are about to differentiate fy with respect to x. Okay, so differentiating it with respect to x, the answer will be 0. because the y and then this constant 12 will all be considered as constant. So this will be 0. Then let's find our fyy. So fyy means that we are differentiating this function with respect to y. Fyy can also be written as f. So we are differentiating a certain function which has already been differentiated in terms of y. We are now differentiating that function again with respect to this y. Okay, so this can be written like this, fxy. And then this is also the same as d squared fxy dx squared. So fyy will be equal to, we'll differentiate 3y squared, we get 6y. We'll differentiate negative 12, the answer we have is 0. So this is what we have for fyy. Now there's something we call the Clairaut's theorem. Okay? Clairaut's theorem. So Clairaut's theorem said that if we have a function which is continuous, and then its first order partial derivative is also continuous, then it means that the second order partial derivative, that is this one, fxy, and then fyx, will always be the same. Okay? So Clairaut's theorem says that if we have a continuous function, and then we found out that its first order partial derivative is also continuous, then it means that the second order partial derivative with respect to the other variable will be the same answer. Okay, so that's what is stated here. We can see that fxy equals 0. Now we can also see that fyx is also equal to 0, right? Good. So fyx is also equal to 0. So that's what the Clairaut's theorem states. Now let's move on. What we have to do is that we need to plot the answers we had. We need to plot the answers we have over here in a matrix. So this is a 2 by 2 matrix. And this is how we have to write our answer. So we have to plot it in a matrix like this. And then we'll find the determinant. So let's say the determinant of this. So let's say the determinant. Let's write it this way. So the determinant of this matrix will be equal to, we multiply this by that, so fxx, that's the principal and diagonal, multiply that by fyy, we subtract the answer from fyx times fxy. Now in some other books you see here written as fyx squared alone or fxy squared alone without writing the two products, because according to Clairaut's theorem, this answer is the same as this answer, so we can write it as just one of them squared. Okay, good. Now we have the determinant to be fxx is 6x, and then fyy is 6y, right? Good. So minus 0 times 0. So we are going to get 36xy to be equal to our determinant. The determinant of the matrix will be equal to 36xy. So now it is from here that we are going to find relative maxima and the minima points. But since my board is already full, so let me claim the question at the top here. I believe you already have the question back. So let me claim that quickly. I want to also claim the function, okay, so that we can use that. Okay, so this is what we have for our determinants. We'll use this to find the points we are looking for. So determinant of the matrix is equal to 36xy. That's the answer we have. So let's pick our point, our first point. So 4 points Q. 4 points Q. Now point Q is 1, 2. Now what we'll do is that we find the determinant. So the determinant using the point Q, will be equal to 36 36, the x here is 1, the y there is 2. So this answer will give us 72. Now we have to check whether 72 is bigger than 0 or whether 72 is less than 0. So 72 is actually bigger than 0. Now whenever you have the answer for the determinant to be bigger than 0, it means that that point will be either a minimum or a maximum. Okay? Whenever the determinant is bigger than 0, the point you have there will be either a relative minimum or a relative maximum point. But you can't know which is which until you found your fxx of this. So to find the fxx of this, from here we have the fxx to be equal to 6x. So if fxx is equal to 6x, it means that we have 6, the x value here is 1, so we have 6 alone. And 6 is also greater than 0, right? So since the determinant is greater than 0, and then the fxx, that's the second order partial derivative with respect to x alone, is also greater than 0, then it means that this will be a relative minimum point. So when both the determinants and this are greater than 0, then the point is minimum. Okay? So since this is the case, then point Q, that's 1, 2, is a relative minimum point. So what we did here, we have to do the same thing for the other points. Okay, so let me clean this as well so that we solve it here. So we'll do the same for the other points. So for points, let's take the next point, R. And R is 1, negative 2. So we find the determinant of R. The determinant with respect to R. We use the 36xy. So the x here is 1, the y is negative 2. We have negative 72. Negative 72 is less than 0. If you have the determinant to be less than 0, you shouldn't even continue to solve, because as long as the determinant is less than 0, the point is a saddle point. Okay? So therefore point R, that's 1, 2, is saddle. It's a saddle point. Good. So let's go to the next point. So for points, so the next point is point S, which is negative 1 and then 2. Negative 1 and then 2. So let's find the determinants of point S. So the determinant will be 36, the x is this, and then the y is 2. This answer is also negative 72, which is less than 0. So this is another saddle point. Okay? This point is also a saddle point. Why? Because the determinant is less than 0. But if the determinant has been greater than 0, then we'll move on to find the fx's. Okay? So also, for points, the next point is t, which is negative 1, negative 2. So we'll find the determinant of the matrix with respect to t. We have 36, negative 1, negative 2. That will give us 72, which is greater than 0. Okay? Now, it means that we can continue to find whether it will be a relative maximum or minimum point. Good. So let's find fxx. So fxx is 6x. That will be 6 times negative 1. That's negative 6. Negative 6 is less than 0. So when this is greater than 0 and then this is less than 0, we say that this point is a relative minimum point. Sorry, a relative maximum, since this is greater and this is less. But if both are greater, then it's minimum. Okay? So the point is a relative minimum point. Okay, so it means that the answer we have for Q from here, Q is a relative minimum. Oh, sorry. Both are greater, so this is relative minimum. Sorry, this is relative maximum. So this is relative maximum. M-A-X-I. Okay? Sorry about that. Good. So Q is relative minimum from here. R is relative Okay, the R and then the S are both saddle points. And then the T is a maxima point. Good. So when the determinant and the f(x) are both greater than 0, it's a minimum point. If the determinant is greater than 0 and then the f(x) is less, then it's a maximum point. If the determinant is less than 0, then it's a saddle point. So that's how we solve questions using this process. So that's how we solve questions on the relative maximum and the minimum point. So thank you very much for your time. You have to stay tuned for more and more educational videos. Thank you very much. Bye-bye.